Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. So while reading the data of a sorting algorithm, there is one more property that we need to keep in mind. That property is called as stability of the sorting algorithm. Now, what is stability? This is a very beautiful concept. Now, what do you mean by stability? Let's take an example of e-commerce. Now, in e-commerce, just think about it. Let's say you have 3 iPhones. Okay. One is a iPhone 13 product red. One is iPhone 13 black. And let's say one is iPhone 12. Now, can I say every single iPhone is going to have a different price? For example, the price is, let's say here, 90,000. Here the price is 85,000. And here the price is 65,000 in Indian rupees. Okay, cool. Now let's say I want to arrange, like this is the only inventory in my e-commerce application. If you will search for iPhone, no. So let's say I will only show this. Now if you have to sort it, right? How can we sort it, and how stability comes into the picture? So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. So let's see. Now just think about it. Let's say if we try to sort it based on price in increasing order. So the arrangement is going to be simple, right? If you try to arrange it in increasing order, the arrangement is going to be fairly simple. The arrangement will be something like this. That iPhone 12 will come here, product red comes here, and something like this. This will be the simple arrangement, right? That this is the least price, then more than that, then more than that. But just think about one more case where the price of iPhone 13 black is also same as iPhone product red, 90,000. Now, can I say that if this is the given input, then technically there can be two sorted arrangements. One sorted arrangement can be something like this. Another sorted arrangement can be something like this. So you have it here. Can I say this is first possibility? This is second possibility, right? Just think about it. If we want to sort them on price, and let's say price is same everywhere in iPhone 13 and iPhone red. So this is also 90,000. This is also 90,000. So if you arrange them in increasing order, iPhone 12 is going to be first. But iPhone 13 red can come before black, or iPhone 13 red can come after black. Can I say both of the arrangements are okay if I want to sort it in increasing order of price? Can I say that? Right? The question was, you have some inventory of iPhones and you want to sort it based on price in increasing order. Now I am saying that, okay, it looks good. All of the three are products, mobile products. If two of them were having same price and I would have arranged it, then this is also a possible arrangement and this is also a possible arrangement. So is there any difference, and does this difference matter to us? Let us see. So just think about a condition that you went to Amazon, I'm just giving you a hypothetical situation. I'm not sure if Amazon does the same thing. I'm giving you a hypothetical situation. Let's say if you have to prepare an e-commerce site like that, you first sort the products by rating. Okay. So let's say you first sorted the products by rating. When you first sorted the products by rating, then iPhone 13 red was having the highest rating. iPhone black was having the second highest rating. 12 was having the third highest. For example, let's say this is 4.7, this is 4.6, this is 4.5. Okay, this is the ratings. So let's say you first sorted them based on ratings. When you sorted them based on ratings, you will see that, oh, if I go by the best choice, doesn't matter what are the price, then though technically iPhone 13 product red is the best one because it has got the best rating. But then you will see that, okay, I don't have that much budget, right? And now I have to even take a look at my pocket that what's the best buy for with respect to budget. Then let's say you resorted the products based on price. Now just think about it. If you go with the first possibility, then iPhone 12 is of the least price, so it came first. But iPhone product red and black are of the same price, and currently they are arranged based on their ratings, because previously they were based on their ratings, right? So whenever you compare two data points which are actually same, then technically, like if I would have implemented an e-commerce site, I would want to retain the previous sorting order. That is, say previously the users sorted them based on rating. If now I sort them on price and price is same for two products, I should still show the product with the higher rating, because that might have been the first preference of the user. So now the user will see the price, and then if the price is same, the user will see the rating, right? But in the second arrangement, I shuffled everything. I shuffled price also, and I shuffled the rating also, right? So that's not the very good design. And maybe this can be based on business. What your business demands, it can be based on the business. My point being, my point being that if you have a set of data that is already arranged in a specific order, and then you sorted the data based on some property, then this kind of arrangement is called as a stable sort arrangement. What is a stable sort arrangement? In a stable sorting arrangement, two data items which were having the same value, after getting sorted, remain in the same relative order as they were before sorting. See? So, stable sort means after a stable sort, the data which has the same value retains the same relative order as it was before sorting, right? That means before the sorting based on price, product red was before product black, and because both of them are having same price, after sorting also, if product red is before product black, that means they retained their relative order. What is the relative order? That with respect to product red, black is after product red, right? So here also with respect to product red, black is after product red. That is going to be called as stable sort. But if that arrangement gets shuffled, then it is going to be called as unstable sort, right? That is, now the relative ordering changed. Previously with respect to product red, black was after it. Now with respect to product red, black is before it. So relative ordering changed, right? For two elements which were having the same value. And I gave you a reasoning also, that maybe based on your business use case, if the user has already sorted based on the rating, you want to keep the rating intact for two phones which are having the same price. In these kind of cases, stable sorting can help you, that you want to retain the original relative order for two data items which are having the same value. iPhone 12 was bound to come first because it was having very less price. Because if the highest priority is price, then iPhone 12 is the choice. But let's say now the user says, okay, 65,000 is too less, I can spend a bit more. Then which phone to choose? Product red should to choose, because it is having a better rating. That's the property of stability. Again, let me repeat. The property of stability says that if there are two data items which are having the same value before sorting, after sorting, if it is a stable sort, they will maintain the same relative order that they were having before sorting. For example, product red was before product black. Then if it is a stable sort, after the sort, product red will still remain before product black. If this ordering gets shuffled, then it is a unstable sorting algorithm. So now we already know the use case that stability is very important with respect to sorting algorithms, right? We have already understood why they can be a game changer. The only sorting algorithm that we know by now is selection sort. So can we make selection sort stable? or first question should be, is a selection sort stable? So the answer is no. The answer is no. Selection sort is not stable. You might get a feeling, that depending on the implementation, it can become stable or it can become unstable, but that's not the case. Let me show you. So this is the selection sort that we implemented. A lot of you might feel that because we have kept a less than icon here, we are not doing less than equal to, we are just doing a less than. This makes selection sort stable, but that's not true. Why you get a feeling that it's stable? Because a lot of people think that, okay, let's say you have something like 1, 2, 3, and then 6, 8, 4, 9, 4. And now you want to get the minimum. So you will try to fetch the minimum index. This is 0, 1, 2, 3, 4, 5, 6, 7. You will assume minimum index is 3 because I starts here. J comes here. It will check. Is 8 less than 6? No. Is 4 less than 6? Yes. So it stores for index 5 here. Then is 9 less than 4? Is 9 less than 4? No. Is 4 less than 4? No. That's it. And then you swap this 4 with this 6. So this 6 comes here, this 4 comes here. So you get a feeling that because this 4 was present first, it is arranged first. And because this 4 was present later, this 4 will be arranged later. But that's not true always. Let me show you a use case why. So better example can be something like this. Let's say you have something like 2, 4, right? And then let's say you have something like a 7 here and a 7 here, right? Then you have a 6, then you have a 5, and then you have a 10. Okay, and we assume that this part is already sorted region. This is sorted, this part is unsorted, so I'll keep I here. Okay, cool. So now we want to get the minimum value that we can put here. Okay, now you see there are 2 occurrences of 7, right? I will mark this as 7 dash, I will mark this as 7 double dash. I will put J here. Now just think about it. We'll keep minimum index as 2 because 0, 1, 2, 3, 4, 5, 6. This 2 is the minimum index for now. And now J will be compared. Is 6 less than 7? Yes. So the better index is 3. We move J ahead. Is 7 less than 7? No. Is 7 less than 6? No. Is 5 less than 6? Yes. So a better index is 5. Is 10 less than 5? No. And that's it. So you found the minimum element to be here. And then what you will do? You will swap this 7 with this 5. This 5 came to the correct position, but the relative ordering of the 7s got changed. This 7 dash was prior to sorting was present to the left side of 7 double dash. Now this 7 dash is coming after 7 double dash. So technically we were never operating on 7, but due to some other number, the relative ordering changed. And now technically nothing will be updated because 6 is already at its correct position. These 7s are already correct. This 10 is already correct, but the relative ordering is changed. Hence selection sort is not stable. We will not consider selection sort as a stable algorithm. The question that should come to your mind is, can we make it stable? Can we make it stable? Right? So technically, you can make selection sort stable, but if you will make it stable, then the only good part about selection sort will be lost. What was the only benefit of selection sort? The major benefit of selection sort is very less swaps, right? Because just think about it. If you are comparing the 2 major operations that were involved in the sorting was what? Comparison. The second was swaps. Now comparison when compared to swapping, is a very less expensive operation, and swapping is a very highly expensive operation. And this selection sort algorithm does, in the worst case, only n swaps. When you compare it with other algorithms, in those algorithms, the number of swaps is very high, right? So that's why selection sort was good. But if you want to make it stable, what you have to do is, instead of swapping, instead of swapping, you need to technically do shifting. You need to do shifting. How shifting? So what you need to do, you will keep 5 in a temporary variable, and then you will move 7 double dash here, 6 here, 7 dash here, and then you move 5 here. Now due to this, what happened? The relative ordering between 7 dash and 7 double dash never changed, and it is still stable. But the only problem is moving 7 double dash here, moving 6 here, moving 7 dash here, and then moving 5 here. These are like expensive operations, because now you're not doing comparison, you're actually changing the value. Just think about it. If instead of just numbers, you have very big files that you need to sort, let's say 1 GB each file you have to sort. So if you remove a file from a place in the disk and put it at some other place, it's a relatively heavy operation, right? Moving files here and there in the memory is a relatively heavy operation, right? So if you have to sort a data which is very heavy in the memory, and we don't want a lot of swaps to go, because swapping can be very expensive. If you are doing file sorting, then swapping can be very expensive in very huge files. So we don't want to spend a lot of time in swapping, so selection sort can be useful. But if you will try to make it stable, the only thing that is useful about selection sort will be gone. The time complexity is already n square, which is not very good. In worst case, average case, best case, every time it is n square, so it's already very slow, right? N square is considered slow. So the only good part will be lost. But yes, if somebody says that no problem, we don't care about less number of swaps, because our use case is stability is more important, but swaps can be avoided. So you can modify your selection sort to kind of like insert things, or by shifting the things to the other side, right? Although this shifting makes it very similar to some other sorting algorithm, there is another sorting algorithm which does a similar thing like this, right? So technically you will get confused that, okay, is selection sort equal to the other sort? So that's why generally we don't make it stable, we keep it unstable, because this property is majorly more important. And if somebody wants to focus more on stability, then selection sort should not be the choice, because selection sort is not meant for those cases which require stability. There are other more efficient sorting algorithms that will help you to keep things stable also, and will sort the things in very efficient manner. So at any point of time, if somebody asks you, is selection sort stable? No. Can you make it stable? Yes, by doing shifting. But by doing shifting, the only major benefit of selection sort will be lost, right? That leads us to the point of use cases. Use cases that where you can use selection sort. We can use selection sort where swap operations are heavy. Example, files or heavy files, right? If the swap operation is heavy, that means selection sort does relatively very less number of swaps, because selection sort only does n swaps, right? So we can use selection sort in that case. Otherwise, there are a lot of disadvantages. Disadvantages we can count, like there are countless disadvantages, like you keep on iterating, so n square for all the cases, right? And n square is already very bad, it's not stable. So a lot of things are there which is not good with selection sort. But the only good part is the use case when you have to swap very heavy files or do a sorting of very heavy data, where swapping can be an extremely expensive operation. Then selection sort might be a good thing to do, right? And this sorting algorithm helped us to actually understand the crux of sorting. Like we understood what is in place property, what is stability, time complexity analysis, the coding of our first sorting algorithm, and so on. Now from here, whatever sorting algorithms we are going to discuss, everything or every sorting algorithm is going to be special in some terms. It is going to have some benefits, it is going to have some disadvantages, and slowly and steadily we will reach to those sorting algorithms which are technically very fast, and generally we also would like to use them, right? One major pointer that I would like to mention, that selection sort is a comparison based sort. That is, in order to rearrange the data, we heavily rely on comparisons. There are some sorting algorithms that are not based on comparison and instead are based on counting. We will also discuss them. So this was selection sort for you guys from my side.